Weather's was bad.
So you didn't get to golf at all?
I no golf, so I'm in a foul mood.
Well, I just ruined them all.
And well, I mean, actually, the weekend was fine, but I was like,
Just
I didn't get to do anything fun. I did some work. All right, quiet, please. Let's be nice and quick. Questions on scientific notation. 339. Nothing?
No.
All right, here's what we got. Did I say 1 day or 2 days? 2 days. 2 days. All right, so we're going to go over this homework real quick. I'll pass out the review sheets. We have 2 ways of doing it. Actually, let's grade this first, then we'll talk about that. All right, any questions? It was just 5 problems. I won't forget to put 0 in the grade book.
Wait, what?
All right, nothing? All right, here we go. Number 27. 3.6 times 10 to the negative 4. Number 28, 5 times 10 to the negative 10. Number 29, 3.6 times 10 to the 17th. Number 30, 1.5 times 10 to the 7th. What are you writing down? Number 31. Okay, this one's silly. Nobody would actually write 1 times 10 to the 0 power. But okay, 1 is written as 1 times 10 to the 0 power. That's good. 32, last one, 1.6 times 10 to the 0 as well. I mean, the answer would be 1.6. The power of scientific notation is to be able to look at a very big or very small number and be able to make sense of it very quickly just by looking at it. But nobody would literally write 1.6 times 10 to the 0. They would write 1.6. Questions? All right, I will collect that here in a second. Say again? 3.6 times 10 to the negative 4.
Okay.
All right, here's the deal. 2 days of review. We have 2 options. 2 options. Option number 1, which is what I would suggest. We go over every single question today. I mean, every single question. I'll hand out the review. We're going to go over every single question. And then tomorrow, I'll just hand out the review sheet and you can work at your own pace.
No.
Or we can do vice versa. Today you work at your own pace. Tomorrow we go over every single one. The only issue with that is if you jack it up today, right, you've wasted the opportunity of practice, good practice, right? If you already know how to do this, then there's no, I mean, we're still going to go 1 at a time, but like you can ignore me and just do your own work. But I would rather go over meticulously the review sheet today, and that way tomorrow, then, okay, I remember this, we just did it yesterday, rather than, well, I still don't get this stuff. And then we kind of wasted 1 day. So that's kind of what we're going to do.
Yeah.
All right. Okay, as I look at Nathan's homework, I see good stuff. Like he did exactly what I said. A number of you are just turning in answers, and come on. I was born at night, but it wasn't last night.
That's funny.
The only thing about, I mean, that is, I mean, the issue is this. I'm going to find out from test day that you're clueless. So we're going to go over this. What I would like to do is give you, I don't know, maybe the 5 to 10 second look at the problem, kind of come up with your own idea of what you need to do, and then we'll do it together.
You mean the Olivia one?
In a second. Best for last, right?
No. Well, it's Lily, so I guess yeah.
Okay. It's coming. So here's the deal. We know as a class sometimes we struggle with being studious, messing around. Hey, I will call out a few names, but Chris, seriously, when we're doing it, really pay attention. Aiden, when we do something and you're clueless, yeah, but I'm saying when you're clueless, you're like, I don't know, he said the answer is 3, I'm gonna write down 3. But when you're clueless on why the answer is 3, you speak up. All right, Kaylee will always speak up and say, I don't get this. Julie will always speak up and say, I don't get this. You need to work on your ability to ask the question. Okay, so we're gonna go over this 1 at a time. The first 2 questions, oh, let me get my e-learners on the right sheet of paper. Wait, I think they're all here. No, Mike isn't here.
Who's here?
Well, I got Julie here. She was the one that was. And Sophie, I don't know if she's gonna watch this or not. We'll see.
Haley is absent.
Share screen. We want to share this.
Sharing is not sharing.
All right. The first two questions, look them over. How many people, without me saying anything, already know I can do this right? Chris, I will buy the class pizza if you can give me the answer to number 2 and tell me how and why you get it.
Wait, are you serious?
Are you that serious? I thought you were gonna say number one.
Be quiet.
That's why I said, oh, questions 1 and 2.
Wait, are you that serious?
We're waiting.
Number two. I figured out number one.
Agreed. But my question was number 2.
Well, I can't help you there.
All right, no pizza.
All
right. But
Can we get him to try
But
at least?
no, because the answer's the last sheet of paper. But Chris, I do believe you can do number 1. The answer is,
3, 6,
what is it?
7, and 6 with the 2 dots.
7 to 6, is he right?
Yes.
He is right, with 2 dots. Now, I never said you had to write in colon form. You could write in fraction form. You could put words, but yeah, most of us write colon form. All right, who can tell me, oh, everybody go to number 1?
No.
Okay, Aiden, when it says write a ratio, there's 3 ways to write a ratio. Fraction, top over bottom, reduced. Colon form, which is what the answer, boy to girl. And lastly, the words, 7 boys to every 6 girls. Right.
How are you even getting the math?
What
So
goes into
what-
14 and 2?
Yeah, that's what I did. Because like 2, 4, 6, 8.
Got it?
Yeah.
So what did the second one be?
335.
335.
Yeah. Not it's like 3 and then.
There's only one issue with ratios. If, and this is a big if they have common units, you got to put them in common units. Well, this is a loaded statement. I can't change boys to girls or girls to boys. They're not the same, but there are people. But weeks and days, I can convert, right? So if I give you weeks and days, is everybody listening? You got to change them all one to the other. Which is the easiest, days to weeks or weeks to days? Days to weeks, right? Because you're dividing by 7. So how many weeks in 21 days? Yes? Rowan's give me, I said you can't change boys to girls, girls to boys, and I was fully expecting you guys to make some statement, but none of you did.
Well, I was
Yeah,
just
I'm so
listening. I would have said, yeah.
Number 2.
All right. On number 2, the only difference between number 2 and number 1 is on number 1, okay, it's a loaded statement. I can't change boys to girls or girls to boys. Right? They're
Well,
separate things.
I mean, well.
Exactly. That's why I said it was a loaded statement.
Oh.
But in general speak, we consider boys or girls, right? And then if I'm doing the ratio of boys to girls, I can't convert boys to girls or they're just boys and girls. Okay.
You know, technically,
I-
gender
I
is
knew
a
that-
social construct.
I knew that would happen.
Okay,
So
let's just say for Tristan that
let's,
boys identify as boys and the girls identify as girls.
yeah.
Technically, what makes boys?
Okay, let's
And-
continue.
And I'm going to tell you, listen, please,
Guys,
listen. On the test, I will use boys and girls and days and weeks.
How about days and them?
All right.
Versus-
Number 2, obviously, now you could have changed weeks to days. You'd have to multiply 35 times 7. That's a large number. Remember, you got to fully reduce. So I think, at least in this particular case, not always the case, it's easy to convert days to weeks. So there's 3 weeks in 21 days. Kaylee, yes? So that would be 3 to 35 and you're done.
How is it 3 to 35 though?
Because how many weeks are in 21 days?
3.
So 3 to 35.
You don't change the week.
Well, like I said, you have the option. If we want to do it the other way around, you'd have to multiply 35 times 7 and then reduce that fraction. And it still would reduce to 3 to 35. All right, questions on ratios. The second one, and I'm going to write this one down. I almost can guarantee everyone has forgotten how to do this. All right. Well, you haven't. The geometry kids haven't because no, you haven't had that chapter yet. We haven't done it. All right. You will also see this again in geometry. Now listen up, please. On number 3, let me show you how it's done. You're going to be given a ratio of 2 or more things. So there's 2. You're going to be told the total between the 2. It says you're doing two things. You're writing and you're revising. You're doing two completely different things, writing, revising. It says together, total, you spend 10 hours. That's including writing and revising. And then it says something crazy like, well, how much did you spend writing the essay? It seems impossible. You ready? Here's how it's done. You see the ratio? Right here, 4-to-1. You put an X on 4. You put an X on 1. Whatever the numbers are, you put a variable on. It's the same variable.
Okay.
You put a plus between them, and together they equal 10. Now we solve 4x and 1x.
5x.
So 5x equals 10. Therefore, x equals, now hold on, stay with me. So we find out that x is equal to 2. Now you'll get all the way here, and it's easy to mess this up. You have to read carefully. Notice the way it is written, it says spent writing to revising. So 4 is what, writing or revising? And it says, how much time did he spend writing? That would be 2 times 4, which is, that's where the answer is 8 hours. Now I could have asked, how much did he spend revising? How many hours did he spend revising? So 2 times the 1. So the basic idea is this. They're going to give you a ratio. You're going to attach an X onto each one of these numbers, set them equal to whatever the total is. Solve. Once you have that variable, then you answer the question, applying that answer to, in this case, to whichever number is, applies to the question. It's 8 hours. There we go. Questions? I usually put this question and I'll have somebody miss it. I'm going to tell you, how do you not miss this? You put this question right here on a resource card. The one that I give you for the test, instead of it being, I don't know, writing and revising, it might be biking and walking. It's the same problem. It just has different words. But how you solve it is done the same way. Attach an X to both of these numbers, add them, set it equal to the total, whatever the total is, and then solve. Questions? It is very easy. We're good to go? All right, moving on. So the next one, all the way to the bottom of the page. Now flip it over real quick to the next page. What is the difference between 4 to 7 and the rest of these? Are they all equations? But look at 4 through 7 and tell me what the difference is. So which one? Is everyone looking at this? I want to point out you could actually use either technique for all. I'm going to show you 2 techniques for the first 4. You could use the second technique as well. However, just these 4, there's an easier technique than clearing the fraction. You can still clear the fraction if you want. Notice on the questions 8 through whatever it is, on one side of the equation, you're either adding or subtracting. Do you see that? Look at questions 8 through whatever. Do you notice that you're adding or subtracting 2 fractions? Yes? Right? So for instance, if I go here, notice I got a 2m plus a 3. I'm adding, and on this side I'm subtracting. On this side I'm subtracting. There's only one thing. All the way on each one through 11, we're adding and we're mostly subtracting. But on questions 4 through 7, it actually is just a straight up proportion. It's an equal sign separating 2 fractions. So even though we could clear the fraction, you can if you want. If you want to just remember one technique, clear the fraction. However, if there is nothing being added or subtracted, just do cross multiplication. Cross multiplication. So cross multiplication. It doesn't matter which one you do first or not. 104 times, you can do this one in your head. 104 times 2. So I get 208 is equal to, I can't write. Is equal to 13x. Do you see where I get the 13x from? The other cross product. And then you divide both sides by 13. All of these are done this way with exception of number 7. 7 is the only one that is, okay, slightly more challenging. Notice on this, do you see the distributive property when you do cross multiplication? It would be 3 times 4a plus 1. So scratch work, 3 times 4a plus 1, Tristan.
Huh?
Tristan, what's the answer? Say again? 3 times 4 is not 15. So 12a, keep talking, plus 2 arrows, plus 3. And that equals, all right, now I need a smarty pants. Who can do the other cross product in their head?
21A minus 28.
21a minus 28.
I'm liking the
All right, does everybody see where I got that from? And now we solve that. Move the smaller of the two first, so subtract 12a from both sides, add 28, divide by whatever, and you're done. So you understand where I got the cross 7 times 3a minus 4? I just chose not to write. If I write that out for scratch work, 7 times 3a, I'm writing with my finger, I apologize. 3a minus 4.
oh my gosh.
7 times 3a is 21a. Yes? Kaylee? And 7 times negative 4 is negative 28. All I did was just do distributive property with the 7. Now I have to solve that equation. Okay? Could you solve that? All right. You are looking at the test right now, other than I changed the numbers around slightly. I'm going to give you 4 of these. It's going to look exactly like this. It's just cross multiplication. You can use, the next thing we do is clear the fraction. You can still use the clear the fraction technique. It's just slightly longer, but not that much longer. So some kids are like, I just want to remember one thing. I'm going to clear the fraction, and that'll work. All right, we good? I didn't get to any answers there, but I showed you how to get to the answers. All right, moving on. Oh boy, right? Clear the fraction. Hey, did I give you any hard clear the fraction? This is it. Did I give you any hard clear the fraction one?
Yes, number 10.
Absolutely not. Notice every denominator does not have an expression. Remember when we did this for real, some of our expressions were like, I don't know, x minus 2, 3x plus 4. I just gave you simple numbers or a variable times a number. It's very easy to see what we need to multiply. All right, which one do you think is the hardest one? Which one?
8,
8's the easiest one.
9, 9, 9.
I hear 9 or 11. Which one?
9.
All right, we will do number 9. Here we go. I will say number 9 is easier than number 10 because look, there are no variables in number 9.
Number 10.
Well, neither one of them is hard. 11 is only more challenging simply because you got to think it through. The denominator is easy to see for number 9, maybe a little bit of thinking in number 11, but the actual multiplication on both 9 and 11, I'm going to give you easier problems like this. All right, you said number 9, let's do 9. Common denominator. So I need to multiply one thing or everything by 10. So I need to multiply 1, 2, 3 fractions by 10.
That's gonna be difficult.
All right, it's just difficult to write, but the math is pretty simple. So I'm going to multiply 10 times parentheses 3y. Oh, my life sucks. 3y plus 5. I really want to do it on the board, but I know the e-learners can't see this. And then Julie sends me an email saying, Mr. C, you have a video of the back of your chair. All right. I did. I know I did.
Wait,
right.
I can hold
All right.
the computer right
No.
here, so it's
No, we're fine. All right. Does everybody see that? It looks like it's challenging. What's 10 divided by 2?
5.
So this is really distributing 5 to the inside. Does everyone see that? 10 divided by 2 is 5. So really I'm distributing a 5. Kaylee, yes? So then I'm just distributing a 5. 5 times 3y is 15y. And 5 times 5 is 25. I mean, it looked like it would be complicated, but it's actually, and that's just the first fraction. We got 3 fractions. Okay. If there's one that will kick your butt, it's going to be the one with subtraction.
I thought you were doing 10 times 3.
Yeah, but 10 divided by 2 is 5. I still need to multiply that minus sign times a 10 times a 3y plus 2. Oh, that's not where I want to put it. Sorry. I still need to do negative 3y plus 2 over 5 and multiply that by 10. I'm putting parentheses. I need to multiply that by 10. That's what's going to clear the fraction. Hey, once again, what's 10 divided by 5? So I'm really distributing a 2, not negative 2, 2. 2 times negative 3 and 2 times 2. So I get negative 6y plus 4, fraction cleared. Who's lost on that? 10 divided by 5 is 2. 2 times negative 3y is negative 6y. Yes, that's a negative 6. And 2 times 2 is plus 4. It's a horrible 6. There you go. That's better.
15y.
That's a 15y plus 25. Hey, the last one's easy. What's 3/10 times 10?
I don't know.
What's 3/10 times 3? 3. Right? 3 times, if you want to do it a long way, 3 times 10 is 30. 30 divided by 10. Or you can say the 10s cancel and you're left with 3. All right. I'm not going to solve this equation now, but it's a pretty simple one. I got a 15y minus 6y. This would be a 9y. 25 and 4, 29. Do a little bit of math there, subtraction. You can get to an answer pretty simple. There's going to be 4 of these on the test. No, I'm not going to make it more complicated than what you see. So when we're done here in about, 10 minutes, if you think these are the hardest ones, these 4, do them all. I can stand by you, watch you, I can give you assistance, right? The ones that you think are easy, save those for essay tonight for homework. The ones that you think are challenging, the ones you think you'll screw up, have me help you. Tomorrow, when we do a review and I hand it out and I say, all right, you're on your own, go to the ones that you think you're going to screw up first. Get those done first so that if you do run into a problem, I can help you. Yeah.
Okay, so you said
I'm going to be done in about 10 minutes. Yes.
okay. And are we eating downstairs?
We are eating downstairs, but let's focus on the math other than other things. All right. So 4 problems. If there's something on the test that takes the most amount of time, it's right here. This is a solid 10 minutes worth of work. That's what we're doing next. All right. I will ask you percent problems. There are many ways these can be asked. The first 3 are basically the same question. Change percent to a fraction. Remember, percent is a number divided by 100. So you simply take the number, what's the number of number 12, and put it over 100 and you're done, other than if you got to reduce. So that one can't be reduced, so that one's pretty simple. The next one is the one you need to remember. So here's what I said. If I give you a fraction, you put the fraction over 100. So what's 3.5 as an improper fraction? What's 3.5 as an improper fraction? 3.5 as an improper fraction. I don't want a decimal, I want a fraction.
7 over 2.
It's 7 over 2. Where are you getting a 9 from? Yeah, but where are you getting a 9 from?
3 times 2 is 6, right?
2 times 3 is 6, plus 1 is 7, all over 2.
Yeah, it's easy.
And I said that a percent is just a number. Here's my number. It's not a nice number. Over 100. So I put it over 100. Do you remember this? Hey, I got a fraction over a fraction. 100 can be written as 100 over 1. Do you remember this as a copy dot flip? Chris, I don't know what you're doing, but you're not paying attention. So tell me the copy dot flip. Remember, the bottom number was 100, and you can always write any number over 1, you change nothing, right? These will always do the same thing. Rowan, give me any fraction. If you have 11 over 35%, 11 over 35%, all you do is take the fraction and you put it over 100. That's step one. So I take the fraction and I put it, 35, and I put it over 100. Second step, Rowan, take that 100 and put the 100, oh, my life sucks, over 1.
It's got eyes.
Because we want to do a copy dot flip. So you copy the top fraction. Let's go back to our problem at hand. Our top fraction is what? So we write 7 over 2. That's the copy. Dot, and we flip the bottom one. Now flip the bottom one. And then we multiply straight across and reduce, and you're done. So that's why we put the 100 over 1. By the way, the smarty pants out there that recognize the pattern, what's the pattern every time? You multiply the denominator times 100 and you're done, other than if you got to reduce. Because every single time when you flip it, it's going to be 1 over 100. So all you do is you take the fraction. Now it has to be written as a fraction, not a mixed number. You take the fraction, multiply the denominator times 100. Every time. Every time you have a fraction percent. So on my bottom one, I didn't need to write this. I could have taken 11 over 35 and multiplied the bottom times 100. Multiply my 100 is simply adding 2 zeros, and we're done. If you know what you're doing, these aren't challenging. Who's lost? By the way, you still would have to reduce. Now, I don't think 11 goes into 3,500, so I'm pretty sure that's the answer. Oh, by the way, this is a made-up one. Rowan made that one up. All right. Our answer is what? What's our answer for the middle one? 7 over 200 and you're done. 14, 540 over 100, reduce that fraction and you're done. Questions on writing a percent as a fraction. Well, the fun continues. Let's see. The next question is one of those weird ones. Do you remember the magic proportion?
Yes.
What is it?
Okay. So of is the top one, right?
No.
No.
Is over of is equal to percent over 100.
So 22 over 100.
Nope.
And then
Is over of equals percent over 100.
And then blank over 70.
All right, number 15. Obviously, the percent is 22.
Yes.
When did we do this? Was it Wednesday of last week? Okay. No, it wasn't Friday. We did scientific notation. I want to say this was Tuesday, but I could be wrong.
I don't remember it back that far.
You just told me it's is over of, so you clearly remembered this. It was last week, though. Okay. Is 78 an of or an is? See what I mean?
78 is an of because of 78.
Tristan knows his reading. Just be careful. It's not always the word to the left, but most of the time it is. Tristan figured out something because he read it like English. Like this is how it sounds right in English. He said it's 22% of 78.
Is what number?
Right.
It's
So it was 2 Fridays ago. Okay. So my X is your is and your of is your 78. Okay. Is this friendly math here? Not really, because you got to do 78 times 22 divided by 100. But I'm just going to point out that if you make it to this is at least 3 out of 4 points. I mean, the other point is, can you do the rest of the math correctly? The kids that don't know what they're doing are going to not set it up correctly. If you don't have this either memorized, and I mean really memorized, some of you thought you had it memorized, then put it in a resource card. Maybe put this example. And no, this is not going to be an English composition class, but clearly 48 is the is or the of, Aiden, number 16. Okay. 32 is the what? Okay. 80 is an of or an is, number 17. You got it. All right, percent is your X. right? Yeah, that's it. I'm going to give you 3 problems just like this. One where you're solving for is, one where you're solving for of, and one where you're solving for percent. In my mind, I'm giving you points. I should just give you one of these. I'm having you do 3 because, well, I'm being nice to you, right? You should easily get all 3 of these correct, minus barring any silly mistake, right? But you should be able to set it up correctly, no doubt about it. You should be able to do the cross multiplication. If there's going to be a mistake, it's going to be because you're multiplying really ugly numbers. Okay. All right. Question 15, 16, 17.
No.
Now we arrive to the homework last Thursday, Friday, and I'm not going to go over this. Just remember, big numbers, positive or negative exponent. Small numbers, positive or negative exponents. Remember, the number must be written in the form of the first number is between 1 and 10. It can be 1 but not 10. And the second number needs to be 10 to a power. Does this 10 mean how many zeros?
No.
It means how many decimal places to move it. Lastly, this was the Friday homework. Multiply and divide. I will tell you this. I will be nice to you. I will give you nice numbers that aren't complicated to either multiply or divide. You can divide, or you can multiply 5 and 2. You can divide 8 and 2. For the kid that doesn't know what they're doing, it doesn't matter what number I put in there, you're going to get it wrong. But for the kid like knows what they're doing, oh, thank God he gave me an 8 and 2. I can divide that easy. Merry Christmas, right? We're not going to spend some time dividing 7.5 by 1.3. You're going to show me you know how to do division and multiplication with scientific notation. By the way, when you get higher than freshman year, right, which is where you're at right there, you usually use a calculator every single time in science class. Pretty much nothing's done by hand. Next year in geometry, and if you have me as an Algebra 2 or pre-calculus or a calculus teacher, I don't care. You can use a calculator on any test that I give you. I don't care. We don't do math that it has any way possible. The calculator makes it any easier. All it does is gets rid of the monotony of math. 17 times 21. That's the purpose of a calculator. Well, I'll be teaching. You can ask the people taking geometry. There's nothing that we do in geometry that involves hard math. It's all easy math. Like 4 plus 3. That's literally the math next year. 10 plus 20. That's the math next year.
That's hard.
So having a calculator isn't going to make your life, you aren't going to get more correct because I give you a calculator next year. But you can use a calculator. All right. That's the whole darn test. Look it over. Questions. I said I was going to be done in 10 minutes. Took me 10 minutes. We have 15 minutes left. Not to sit there and make messes next to your desk. Not to sit there and talk with the person next to your desk. But to sit there and do this work. Some of you are probably only have it done because you're very, self-motivated. Right? Others of you need the motivation. That's what I'm giving you right now. Get this done. We got 2 days, right? 2 days, today and tomorrow. Tomorrow I'll just give you the same kind of questions. I'm just going to change the numbers. And then on the 3rd day, right? Sounds like I'm making a biblical statement here. And on the 3rd day, I'm going to give you the actual test. Questions. All right. If there's a test that you can make a B or an A on, it's this test. Is that right? There's no surprises, none whatsoever. Right? Clearing the fraction computationally wise is the most challenging, most work. But you still know the process. Right? It's not that much. It's not that bad. All right, get to work. 1 second. E-learners, anybody online? Mike, you online? No, you're not. So I'm going to stop the video right here. You just heard my comments. Tomorrow will be the same drill. I probably won't have the video going for the whole class unless you show up with questions. You show up with questions, we'll throw the video the whole time. But if you don't show up, then I'm already going to say, here's the practice test. Send me a chat or email if you have questions. You should. It's pretty simple.